Alluvium refers to a sediments that is transported and deposited by water. Alluvium is found in rivers, lakes and along coastlines. In the case of alluvium that transported by ancient streams, alluvium can also be found in a terrestrial environment. The alluvial process can transport and concentrate a valuable minerals. Over thousands of years, minerals are eroded from their source and transported by water to a new locale, because sediments settled out of water according to their weight. Heavier valuable minerals such as diamonds, platinum group of minerals and gold will often deposit at the same time, and this characteristics can lead to a concentrated deposits of valuable minerals for prime location for extraction. Alluvial mining is an ancient technology. The earlier gold panners were alluvial miners, although a small scale alluvial mining operations are still common. Alluvial mining has also transformed into a big business involving cutting edge technology and a great deal of capital investment. Alluvial mining is the process of digging and shifting mud, sand and gravel using shovels, and they can put it into a sieves or even a bare hands. This process mainly includes the extraction of minerals like diamond, gold, etc. Typically, the diamonds come from geologic rock formations called kimberlites. Kimberlite rock formations that contain diamonds are eroded over a time by rivers and streams and are deposited in the sediments. These deposits are called alluvial diamond deposits. In the case of alluvial deposits that are cut off from their water source, mining is simple. The resource can be extracted through a convenient or conventional open pit. If the deposit is still covered by a water, the mining process is a bit more complex. If the water is shallow, such as lake or adjacent to a coastline, a wall may be built and pumps are used to pump out the water. The overburden is removed and then the deposit is excavated and transported by screening. The dredging is used to remove the overburden in areas with very wet ground conditions. The dredge is floated in an initial pond and then moved into the mining blocks, where it is excavated down to the mineral bearing material. Heavy stable minerals weathered from rocks are deposited in stream beds to form a stream placer deposits or alluvial deposits or alluvial placer deposits. They may be carried away, accumulated and in the beaches to form a beach placers, where mechanical sorting actions of water flow tends to layer them below the fine sand of gravel. Generally, only the heavier minerals will be sorted and left. For example, minerals having their specific gravity are as follows: gold having 15 to 19, platinum 14 to 22, cassiterite 6.6 to 7.1, diamonds 3.2 to 3.52, garnet 3.5 to 4.3, monazite 4.9 to 5.3, magnetite 5.6 to 5.18, zircon 4.2 to 4.7, rutile 4.2, ilmenite 4.5 to 5 and silica is 2.6. Alluvial mining methods includes the following processes, namely panning with pan and bottia, panning with rocker, panning with long tom, sluicing, generally ground sluicing. then hydraulic using gains or monitors, drift mining, dredging, derricks and cableway, panning with pan and bottia. This is a manual method of mining where picks and shovels are used in excavating sands, sandy clay, etc. Pans of various shapes and sizes are employed in recovering the valuable minerals. For normal work, the pan used in about 10 inches wide at the top and 3 inches deep with the sloping sides. The soft alluvial material dug up is placed in the pan or bottia and washed. This process is called a panning. Panning with rocker. The rocker consists of a metal screen mounted at the bottom of the strong wooden box. The box is made to stand on two semicircular iron hoops. A handle is fitted to one side of the box. The alluvial material is poured on the metal screen, just about 1/4 inch to 1/2 inch. Together with the water and with the help of the handle, the rocker is rocked from side to side. During this process, as the rocker rolls on the semicircular iron hoops, the finer portions of the alluvium containing values passes through the screen along with the water and gets into the riffle box. The lighter fractions flows over the riffles, while the heavier fractions is retained by the riffles, from where it is collected later on. The gold is separated from the magnetic materials contained in the heavies by magnetic separation. Long tom. The long tom consists of an open box 10 feet to 12 feet long, from 15 to 20 inches wide at the upper end, and nearly double this is fitted. The slope is given 1 in 12. The finer material passing through the screen falls on to a riffle box. Here the separations of heavies is affected. This equipment is also used where manual excavation of soil or alluvial materials is carried out. Sluicing, that is ground sluicing methods. Water from the flowing stream or river is diverted into the area occupied by the alluvial deposits through a channel and then standing on the banks of the channel. The placer materials obtained from shoveling is put into the sluice box or riffle boxes, which are placed in the bank, from where the concentrates is recovered. Using a sluice box to extract the gold from placer deposits has been common practice in prospecting and small scale mining throughout the history to the modern day mining. A sluice box is essentially a man-made channel with riffles set in the bottoms. The riffles are designed to create a dead zones in the current to allow gold to drop out of suspension. The box is placed in the stream to catch the water or flow, and gold bearing material is placed at the top of the box. The material is carried away by water through the box, where the gold and other minerals which are there and get settled in the riffle boxes. The larger commercial placer mining operations employ a screening plants or trommels to remove the larger alluvial materials such as boulders and gravel before concentrating in a sluice box or a jig plant. These operations typically include a diesel powered earth movers, equipments including excavations or dozers, wheel loaders and rock trucks. The conditions which are favorable for ground sluicing are as follows. Shallow depth of the deposits is around 6 feet to 8 feet. Sufficient gradients facilitating the transport of placers, it is 5 to 10 meters per kilometer. Then copious supply of water, facilities for disposal of tailings accumulated due to the fall of gradient. The gravel should not be more than 3 to 3.5 meters deep. Hydraulicking. Hydraulic mining uses a power jet of water which removes the unwanted material from the gravel. This was used in the 18th century to find out a gold after placer mining had already been used. Miners make channels where water under pressure could be sprayed on the rock or a gravel hillside. The water pressure broke down the rock and washed a large chunks of it to a downhill. The miners used this method to find the gold in a quicker way than panning. So, they use the sluice boxes so that where they can collect the material with the help of hydraulicking. The water is sent down the sluice boxes where the gold rocks and gravels drop to the bottom. The gold is separated from the rock and gravel. Some of the principal problems encountered in this method: there is adequate water supply under pressure, suitable sluice grades, then availability of room for dumping waste materials. Drift mining. This is more expensive than either sluicing or hydraulic mining. It is employed in the exploitation of placers occurring underground at depths such as buried beach placers and ancient river channels. Forepiling is employed in advancing the working in the deposits. These main entries in most cases are vertical shafts. Dredging. Dredging method is essentially employed for mining placers, particularly tin, as in Malaysia. The dredge is large flat bottomed barge or pontoon. These dredges are provided with a chain of large shallow buckets which is lowered down or lowering bring up the soil from the pond. The bucket is carried up by a Persian wheel, and this form of dredge is advantageous in clayey soil as dredging is not difficult. Headlines or stray wires are used instead of spuds to keep the dredge anchored. Sometimes the mechanical arrows delivering 60 strokes per minute are employed for loosening the mud. Some dredges are fitted with classifiers and jigs for recovering values. Trommel or revolving screen feeds into a classifier where final concentration goes from the trommel to a jig. The different types of dredgings are resoiling dredge, frozen ground dredge and centrifugal pump dredge. Derricks and cableways. The derricks in common use consists of a stout wooden mast which can be used to lift loads by means of a rope and pulley arrangements. At times this can be improved by attaching an inclined member which can move round the vertical mast as well as move up and down. By these arrangements, loads can be moved outward from the mast as center as well as concentrically. The cableway comprises a two masts, the tops of which are connected by a tight cable. A pulley arrangement is mounted on this rope and this can run on the cable from one mast to the other. The pulley can be used for lifting the loads, while the wire rope, that is cable, is used for moving the loads outwards. The derrick and cableway are used in open cast methods for winning the clays etc., or for removing the clays overburden from the excavation to the surface for storage or dumping. Diamonds are a popular resource extracted through alluvial mining, particularly prevalent in Africa, around 10% of the world's rough diamonds are sourced through industrial alluvial mining and 14% through artisanal or small scale informal alluvial diamond digging. On the industrial scale, when a diamond are found on the ocean shore or river beds, the gravel is removed and then taken into a plant where it is washed and screened for diamonds. For offshore operations, specially constructed ships sunk into a gravel from the ocean floor before it is transported to a land and to plants for screening. Formal alluvial diamond mining mainly takes place in Angola, Namibia and South Africa. Mining kimberlite pipes requires a more advanced degree of mining technology and is more expensive. The first step in mining a kimberlite pipe is to dig the pit. In open pit or open cast mining, the layers of the rocks are dug up and eventually the tunnels and pipe are built so that the hard ore material can be removed with large hydraulic shovels and trucks. The hard rock is broken into pieces with shovels and other methods until the rock is small enough to be removed from the mine by trucks. When the kimberlite is deep underground, it must be removed by mining a series of underground shafts in the pipe that allow the ore to be carved and make its way down to the tunnel to draw a point. At this point, this crushed ore is brought up to the surface for processing. Only about 20% of the world's diamonds are taken from pipe mines and the remaining 80% of diamonds are alluvial. Alluvial mining for gold. Alluvial gold is commonly found mixed with loose sediments due to its high density. Over the years, a variety of techniques have been utilized to separate the gold from the gravel. However, all these methods really on same basic principles: water washing of the gold bearing gravels, etc. Alluvial gold is commonly cemented, and these cases the extraction of is a bit more difficult or more complex. Drilling and blasting is employed to remove the worthless ore burden, although unconsolidated sediments are much easier to extract the gold concentrations in these deposits. Alluvial platinum mining was first used in the Urals back in 1823. By the end of the 19th century, the alluvial deposits of the central Urals had become the world's dominant source of platinum. The most easily accessible high grade placer deposits, however, had already been exhausted by the end of the 1920s. Nevertheless, the Urals are currently receiving some technology or some renowned interest using a present day technology explorers for examining the presence of platinum with the help of alluvial mining. It is possible that a great deal of platinum that was too fine grained to still present in their region. Furthermore, the possibility remains for undiscovered sediments that were buried too deep to be found with 1920s technology. Alluvial mining is alive and well in the far east of Russia. The platinum group of metals are currently mined from river sediments. The first bulldozers scraps out the bottom of the river bed. The material is then made into a sluice by using hydraulic guns to break up and wash the ore. This causes particles to fall through a mesh into a collectors. Then further washing is completed in stages to separate out the precious metal grains. These are collected and passed through a final gravity concentration stage and shaking table to separate a PGM, that is platinum group of minerals, and gold concentrates. This region is known to host some very large platinum grains. The largest nuggets discovered to date weighed 3.522 kg, around 3 tons of platinum per year have been extracted from this region since 1990. It is thought that the production in the range of 3 or 4 tons per year is sustainable for some years to come. Today, diamonds are mined in about 25 countries on every continent, but Europe and Antarctica, although most of the diamond mining is accomplished by large companies in many developing countries, diamonds and other minerals are extracted by small scale miners working in the informal sector. These small scale miners often use a simple artisanal mining techniques in alluvial deposits. The process of alluvial diamond mining involves digging and lifting through a mud, sand and gravel using shovels, sieves or even a bare hands. Typically, diamonds come from geologic rock formations called kimberlites. Kimberlite rock formations that contain diamonds are eroded over a time by rivers and streams and can deposit diamonds in the sediments carried by these the original source of rocks. These deposits are called alluvial diamond deposits, are controlled by the surrounding topography, drainage patterns and the location of the kimberlites. Alluvial deposits are often mined and exploited by small scale miners using artisanal mining techniques. Artisanal mining techniques results in working with simple tools and equipments, usually in the informal sector and outside the legal and regulatory framework. Artisanal operations are characterized by the low productivity, lack of safety measures and high environment impact. As a result, the majority of the artisanal miners are very poor, exploit the marginal depositions with minimum returns, and they are also exposed to harsh and often dangerous conditions. Artisanal and small scale mining occurs primarily in rural areas where they represents the most promising, if not the only income opportunities available for them. However, the mining activities are often viewed negatively by the government, the large companies and environmentalists. The use of child labor, the potential for environmental degradation, etc. Further, the potential use of ASM revenues to finalize or to finance the conflicts and irregularities to host the countries of even a regional scale conflicts. The alluvial mining method is cheaper, easier and low cost mining methods. It is easy to extracting the placer deposits compared to other mining methods. This method has a greater safety and provides better working conditions in respect of light and air. Diamonds are the pure form of carbon in a transparent state that is formed below the surface of the earth, over 150 kilometers below the earth's surface. In the mantle, diamonds are formed. The diamonds make their way of the surface captured within the liquid hot rock or magma. Once they reach the surface, diamonds can be found in volcanic pipes called kimberlites or kimberlite pipes, or in loose mineral deposits called alluvial deposits. Alluvial mining is employed in coarse unconsolidated deposits such as alluvial gravel or mineral sands.